let's find out if I'm in the right place and if the stream is gonna work. Usually, let's see, Twitch usually starts first. Twitch starts first, here we go. And YouTube eventually joins in. Here we go. This is YouTube. Yeah. Wait, is it? Looks like it is. Okay, I think we're live. Welcome to Hangout number 167. Today, we're going to look into skinning the app, as in thematic changes to visuals. But first, I'm going to drink my coffee. Secondly, I'm going to have a quick look at this script, which is for, I've been working on the last day or two, which is for solving 1+ puzzles, so I can add solutions to that kind of puzzle. And here's one, I believe, where it currently fails, or not. Let me just move these somewhere else. Can I squeeze them in here? No, I'm gonna squeeze them in here. Oh, and let's hope I don't lose this because it's all important unsafe data. Let's just run the script and see what happens. Yeah, so it's a very simple solver, and I could probably just make a backtracking one that's just sort of universal. Oh, why does it say YouTube isn't running? Wait, but YouTube is running. Restream. Uh-oh. 1 second, maybe it's just a chat. Maybe it's just a chat. Did we get... 1 secondo. We didn't get the chat message there. If I do that again, nope, not that. Oh no. 1 sec. If I do this and then send it to YouTube only. Hello? Connection in error state. Why? Oh, come on. For some reason, my Restream chat isn't working. Which means I'm gonna miss either YouTube chat or the Twitch chat. Well, I'm not sure what I'm gonna do about it. Alright, well, let's hope it sorts itself out. Not much I can do right now. I'll just, every couple of minutes, I'll check both chats manually. Actually, maybe I can move one of these up here, perhaps? Or down here, if I do this. I'll do this, and then move that over. Yeah, maybe that's good enough. All right, so this is a what are they called? One up puzzle from oneuppuzzle.com, and I just want to solve them. And this is a particular one which I'm rendering here in beautiful ASCII art, very old school. And this is basically let me just reset. So basically you have a puzzle like this with some given digits and some lines in it, and the lines designate zones or ranges. So for example, this line says this is a zone of 2 digits with the digits 1 and 2 in it. So there's a 1 and 2 in here, and there's a digit with 1, 2, 3, 4 in it. So 1, 2, 3, 4, like that, right? This is 1, 2, 3, etc., etc. And then this would have, 8 digits total. So it's always from 1 to the number of digits that have space. But of course, this digit is part of both a row and a column. And in this column, it can only be 1 or 2. And in this row, it can only be 1 and 2. In this column, it can be 1 through 8. Which means it must be from 1 to 2, and it can't be a 1, so it's a 2, right? And that's kind of how it propagates. So it's kind of a very simplified version of Sudoku in some ways. But I feel it might be almost like a good exercise for practicing certain basic techniques, like singles, pairs, and hidden singles, hidden pairs, and all that sort of thing. So and I've solved a couple of test puzzles I had, and they worked fine with these basic techniques. But here's one that doesn't work fine, and I'm guessing. So what I'm currently looking for is, first it's saying, okay, given digits, and first it puts in all the possibilities, then resolves all the given digits, and then any other digits where like in this case I got a 2, so I can remove a 2 from here, and obviously that gives me a 3, and then it gives me a 2. So it resolves all the singles, then it looks at pairs, and then it looks at hidden singles. And the next technique I was going to look at is hidden pairs, and I don't even know if there are any. And what you see here is basically initially the possibility. So for these 8x8 cells, these are all the possible digits in each of the cells, and then it goes through a solver and it gets to this state, right? And this state is not solved, and it basically is quote unquote stuck there. And now I have to figure out if there's some technique that I can add that will get it unstuck. And if it doesn't work with hidden pairs, I'll probably have to do a backtracking solver, which shouldn't be too hard because I think these converge fairly quickly, and I don't actually care about I don't care about a proper solve path. I just care about finding the solution so I can add it to the data and get it to solution check correctly. That's basically all I need. It's like I'm gonna crank up the AC because the moment I start streaming, I get hot. All right, so here basically what I did is I found all the ranges of digits. So I'll find these 4 digits, these 4 digits, these 7 digits, etc. Right? And I pass them into this function, and the range is basically just a list of indices. And I have, via the indices, I can find these guys, and from these guys I can find how many digits there are in each, which possibilities there are left, sort of thing, right? So for example, for the hidden singles one, I basically just I count how many, and that's how I start here. So I'm basically counting how many of each digit there are, right? And then for the hidden singles, I said, okay, whenever there's a count of 1, I know, for example, if there's only 1 5, then I know the cell that has, if in that range there's only a single 5 available, then the cell that contains the 5 can only be that 5, and I can remove all the other options from that cell. That's a hidden single, right? And hidden pairs are kind of similar. So, for example, if there's 2 cells. So for example, right, if I found a count of 2 for the 1s and a count of 2 for the 2s, and they are on the same cells, then those 2 cells can only be those 2 digits, right? So it's a little bit more complicated and a little rarer, but at least the mechanism is relatively simple, so I should be able to implement them. And I'm just kind of curious, because these techniques, ultimately I'd like to have a Sudoku solver as well, and these are some basic techniques that a Sudoku solver needs to know, and implementing them a million times over, eventually maybe I'll figure out how to do it well. That's kind of the plan. So here I'm saying, well, you know what? First I'm gonna actually output the counts. So I'm just gonna count, and then I'm gonna output them for each range, and then I'm gonna see what that looks like, right? So for example, here, for each of the ranges, we have the digit counts, right? So for example, and let's output the range as well, so we know what, and the range is just indices, so we want to map them. So map, we have an index, and we want to map it to the actual digits for that index, right? Digits is not a function. Oh my god, the number of times I've done that. No, it's an array. Here we go. So for example, let's look at the first one, right? So this range would consist of, I don't know which particular range it is, but the first cell in that range can be a 2 or 4, then a 1, 3, 2 or 4, and a 4, right? Sorry, length 4. And here we have... What? These counts seem inaccurate. Let me stringify that, because maybe it gets messed up with later. And then by the time I've unfolded here... Yeah, okay, it got messed with later, so that was kind of the problem. In fact, when am I calling solve hidden pairs here? Am I even calling solve hidden pairs yet? 1 second. So we're calling solve. Oh, okay, yeah, because I integrated straight with the solve. So here we're doing singles and pairs, hidden singles, and now we're going to do hidden pairs. Okay. All right. So as an example, right, these 4 numbers represent the counts of 1, 2, 3, and 4. So it says, okay, there are 4 1s, there are 4 2s, 4 3s, and only 2 4s, you know. So we want to find something where we have 2 digits that are both count 2. For example, here we have 2 3s and 2 4s, for example, and they happen to be in the same one, so we know this can't be a 2. Now, in this case, the singles will actually resolve it first. So hidden pairs is probably something we want to do later. But, you know, let's just go to that step, and then we can kind of look into it more deeply, right? So let's do this if we find a count with a 2. Right? And only then are we going to log it out, so it should be a lot fewer of these. And you know what we're going to do is actually we're going to do it in a separate solve step. So we'll solve everything that we can without hidden pairs, just to reduce the noise, and then we're just going to run the hidden pair solve afterwards, right? So here we just keep solving, and we're going to output that, and then we're going to do one more solve, 2, and then we're going to output again afterwards, and that output is just these boxes here, right? And then we're going to comment this one out so we don't have the spam. Here we go. All right. So, and then we have one extraneous one. Let's just going to run that one so I don't confuse myself. Okay, so between this state and this state, we have all these options, right? So for example, we have a count of 2 on this particular digit, right? So we need to find another count of 2 on the other digit. So, well, actually, no, we need to find a second count of 2 that hits the same 2 cells. All right, it's a little complex and a little messy, and I kind of want to express it in a simple way. Like, you know, it's not a hard piece of code to write, but for me, it's a bit hard to kind of write it simply and compactly. Is there a better way of expressing this? I'm thinking right now. Because, for example, we don't actually care about like this. It doesn't help us because we have no extra digits to remove. But of course, that, you know, we're probably fast enough that we can just look for all these cases and then just operate on them. So what I really need to do is I need to match all the count 2s. So we don't care for any that aren't count 2s. Right? So here we're looping through all of them. But actually it would behoove us to kind of filter them. I'm just trying to see, like, given something like this, how will I get a set of these, right? I'm just trying to think if there's some trickery we can do with creating a hash, you know, like a JavaScript object indexed to the actual digits that will give us that more quickly. Like every potential pair. I mean, like for 8 digits, there's only 64 potential pairs, right? Because, for example, now I need to know which cells this digit is in, right? Which 2 cells this digit is in. And this actually doesn't give us that. So what if I just return here? This will only execute once, right? No, it'll execute once for each range. Okay. At least it's less stuff to look at. But I'm starting to feel that hidden pairs is actually... I'm really just curious if hidden pairs are actually relevant here. because I don't know like what the human next step to solve should be. Maybe we'll actually transfer this. Is this actually this puzzle? I don't even know. It's not this puzzle. I'm just trying. I'm looking at these numbers now and just trying to figure if there's a humanable way of solving these. Like how, as a human, you know, how would what would be my next step here? You know what? It doesn't matter. We don't care, right? We don't need a humanable step. So this is a complex technique. If in that time I can just build in an iterative solver, a recursive solver, a backtracking solver, then that'll be a lot easier, right? So to do a backtracking solver, we need to have this basic solve function, and then until we basically have no more solve steps, which is basically what this line does, right? It finds it exits either when we have a solution or when we have no longer any solve steps. And then we basically need to find the first element to basically the first cell that has more than one option, pick an option, and then continue from there. Basically, and ideally we'll sort the options by the number of cells, but maybe that's also too complicated, right? Maybe it doesn't matter. So we have solve here. We have solve here. Ranges and digits. Are we using digits for anything else? Yeah, we might as well. I mean, if we're passing ranges, and we might as well pass digits in as well. Right. And then instead of returning res, this part will become basically this becomes a solve step function, right? So we'll have something like that. We might as well put that in here for now. We can just use the outer scope, right? And then we'll put that in here. While digits are flat, or blah, blah, blah. Solve step. Right? And then at the end, we'll do this. And for now, we're just gonna do that in here. We'll get the digits out here as well, because we'll just use them for other things. Or do we need them for other things? Digits.flat. No, we don't need that, right? That's just solution. So if I do this, and then we'll do, we'll just do solve. We can do let solution equals solve. Right? And let's run it on something we know works before, so I don't mess it up. Digits is not defined. Digits is not defined. All right, let's get the digits here. Oop. Reading math. Solve hidden singles. Range. Cannot read properties of undefined. Try. Catch. Will that get us a stack trace? No. It's gonna give us even less of a stack trace. Promise rejected throw. But why doesn't it console error the error here? The heck? Console.error error. Are we filtering errors out? Why were errors off? That's so bizarre. What the hell? Okay. That must have been a fat finger thing. Is that it? Is that why I wasn't getting the errors before? If I get rid of that, will I get errors again? Now that I'm not, you know, disabling them in the... Yeah. Wow. Okay, how long was I debugging with errors hidden? Alright, that makes it a lot easier. So solve steps, solve hidden singles. Anonymous 114. Digits range. Digits. So these should all be inside solve as a closure. So I think we'll do that. And then just do that. Like that for now. Right? Later on we'll encapsulate this whole thing. We'll get to it. Fulfilled undefined. What's going on here? Okay, we've got the digits. Ah, wait. And solve step. Yeah, that's our solution. Solution is the result of solve. And then we have a console log solution. And then we have a return statement that we didn't remove. That'd be the problem. Here we go. All right. Okay. So this still seems to work. Does this look correct as a solution? It's probably correct. I'm just gonna assume it's gonna be correct. It's good enough for me. Okay, and I think this, we're just gonna move in there. So basically we'll output that. Right, and then we're gonna output it down here. And then I don't think we need digits down here anymore. Solve failed. We're just gonna say that and pretend we don't need that anymore. Because givens.length is just how big the puzzle is. Okay, now we can go back to our test case, which now I don't recall. I think it was the last one, right? Our breaking case. All right, so we have solve failed. We're back to here. And now we can recurse in here. So, and the reason I'm doing this is so we have all the closures, and now it's easier to kind of call something, whatever it's gonna be itself recursively, right? So now we need to figure out how we're going to select one path of the solve, right? So we can get to a point where, givens. Give me a second. Get digits and get ranges. Givens and get ranges. Givens. Map. All right, we're gonna worry about encapsulating things later on. So I think we can do the same thing here. We can just do that inside here, really. Boom. Like that. Boom. Net solution. Boom. Now we can just return that here. I'm just cleaning things up a little bit. It's awkward code. Just build it on the fly. Never even saved this file. So let's hope nothing happens to my computer. In fact, I'm gonna pull that out and give myself a tiny little bit more space. But then will it be cut off for you guys? Yeah. I forget that on the stream you don't actually see the leftmost edge of my screen. Line numbers, who needs them, right? So, what are we looking for? So we moved from this state to this state, and we know if this, then solve failed. Right. Now, when we fail a solve, I think all we need to do is change the digits thing in a way that we can backtrack out of, right? So we need to know what we've done, what we've changed. Okay, so, and then we basically kind of just loop back around to the top, right? So ideally we'll have something that we can solve. And one of the problems is that we are currently sharing the digits amongst all of these, which is a little bit problematic. That I've made it sort of global. Okay, well, let's just see what we can do. So, boom. So now we want to do, I'm just going to output digits raw because I'm always transforming it, so I don't even remember the structure of it. So basically what we need to do is we need to find a digit here. The first digit that's has an option of 2. I think it's better to pick one from 2 rather than from more than 2. Or maybe it's better the other way around. Maybe we don't care, right? So what we're going to do, we're going to do find a digit where d.length is greater than 1. So if I do this, right? We'll get that, right? Okay, so we'll say let dig equal blah. Right? Then we'll do dig.length equals 1. And for now, we're just going to do that. But what we're going to do in reality down the line is we're going to mark all these actions so we can then try the next one, etc., right? So obviously, this might not be a 2, it might have to be a 4, right? So we need to go, you know, be able to back out of that. And now we're going to do that again and see what happens, right? So we went from this to this, and it's still not solved. Now, what I'm not sure about is how we're going to detect a contradiction, i.e., when we've basically put in the wrong digit, or if we're just going to have to keep doing that. So what I'm thinking is these two lines are our sort of try-solve step, right? And while the try-solve thing, so we want to have a function, right? We want to have something like const try-solve. Right? Which basically does this. Outputs, you know, logs that. So we'll do try-solve here. Boom. And then we'll check if the solution is yada yada. So we'll do that. if solution is unequals to blah blah blah. We're just gonna return this for now. So return. So let solution. Then we'll do solution equals try solve. If solution.length equals givens.length, yada yada. Right? And then we'll do that again. Basically. Except recursively. So ideally we'll do it from inside try solve. So let solution equals boom. Solution. Now the problem is, if I'm not careful, and I don't have an exit clause for having chosen wrongly, and my brain is not telling me obviously right now how I detect the contradiction. In other words, what's the difference between not seeing the next step with my primitive algorithm versus there not being a next step? Because now, okay, I can repeat the step, let's say over here. Maybe we just manually repeat it until we hit that state for now. So we'll just do something like this. How am I doing? Dig 0. Right? And then we'll just do it again. We'll just assume this will have failed. In fact, we're not even gonna do this step here for now. Dig. We'll do that. Do that. Then we'll do that. And then we're gonna repeat that. Right? And then let's see what the second dig is. So we'll choose from 4 or 5. Okay, now if we do it again, it found a solution. Now, is that solution correct? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So far they're looking good. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. This all looks correct. Okay, so that unfortunately means so instead of so if I now do this dot splice 0 1, right? Now that should not be correct. And to remind myself what it looks like when it's correct, let's copy that out here and we run that. We haven't resolved yet. So if we just keep doing this, it shouldn't solve, obviously, because we made a mistake, if the first one is correct. So we'll get to a state like this, and eventually, I'm curious now, like for example, one of these, we're just going to replace a 7, 8 with a 7. Now it solves, but it can't be correct. Right? It can't be correct. Or I'm misunderstanding. 2, 1, 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. I should write a quick checker actually. 1, 2, 3, 4, 2, 1. Ah, you know what? What's the check? It's the counts. Const get range counts. Const get digit counts. I'll just do that, right? Because what we then can do is, let's just make sure this still runs the same way. And then the end, whoops, at the end here, where I'm kind of presuming that it's incorrect, we'll take the ranges, map them, get digit counts are. Not entirely certain what that'll look like. It's a bunch of arrays. And they're all ones. Which implies they're correct. But they're different. Unless these things don't have unique solutions. Maybe they don't have unique solutions. Maybe they don't have unique solutions. I never even thought about it. Maybe they don't have unique solutions. Oh. These may not have unique solutions. Which is really bad because SudokuPad only normal Sudoku checking won't work here, and to get decent checking I will have to shoot. So then the other question is, does my primitive system find all puzzles that have unique solutions? In other words, if this fails, does that mean we have a unique solution? Huh. I kind of want to make a simple function now that basically just returns true false. So I can run it on a whole bunch of things. Oops. So, you know, in this case, it would come back as not unique. Let's skip the ASCII output for a sec. Then we'll skip this output and this output. Where does that leave us? It gets us to here. Right. Clear that again. Solve failed. Okay. But if I pass one in where where I know it finds a solution, but there's no guarantee that this is unique, is it? No, I think if it resolves using these techniques, it must be unique, right? Because I don't think these techniques can be resolved any other way. Or does the order of resolution of the technique matter? Now I'm worried. I'm trying to think. I'm gonna ask Ranks about this. Because the other option is to find all the possible solutions. Ideally, I'd try to... Hey, Shelby, how are you doing? Because the other thing I could do is, because these resolve relatively quickly, I think, and there aren't that many options, I could exhaustively search for all possible solutions with a backtracking algorithm. And then at least of the list that I have, I could find all the ones that have a solution. But first, I would need to know if my algorithm currently will actually... Yeah, I mean, So this is the example that I have. So for example, we have 1 here, we have a 1 here, 1, 2, 1, 2, 1, 2, 2, 1, 2, 3, 1, 2, 1, 2, 1, 2, 5, 5 here, 1, 2 here. Wait, what? Ah, no. I thought this was seeing these, but it's a separate one. Well, it can't be a 5, so the 5 is here. 1, 2, 3. That's only a 1, 2. That's a 1, 2. 1, 2, 1, 2, 1, 2, 1. 3. 3, 4. 1, 2, 3, 4. 5, 4, 5, sorry. 1, 3, 4, 5. 1, 2. Yeah, so this definitely only has one solution. Like I think I can easily confirm this. And this is from a set of practice puzzles, so I wouldn't expect them to have more than one solution. I kind of would expect them to be correct, if I may say so myself. 1, 2, 3. 1, 2, 1, 2, 1, 2, 3, 2, 3, 3, 2, 3, 4, 5, 2, 1, 2, 1, 2, 3, 1, 1, 2, 2, 1, 3, 4, 4, 5, 4, 3, 2, 3. No, 3, 2, there. Yeah. I mean, this is, I think I'm pretty confident in saying that I can manually confirm that there was no other options, right? Let's solve this one. See if there's any ambiguity. Ambiguity. My God. All right. 1, 2, 3, 4. 4, 1, 2, 3, 4. Not a 3. That's a 3 here. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. Okay, 1 here, because that's a 1, 2 here. 1, 2, 3. 1. 1, 2, 3. No 3 here. That's a long run here. Very long run. That's a 1. 1, 2, 3, 4, 5, 6, 7. This one cannot have a 6 or 7 in it. So that's a run of 5. Oh, that's not a 5 anymore. That's a 3. 1, 2, 4. 2, 4, 2, 4. 2, 5 on both sides. This one doesn't have a 7 in it. 1, 2, 3, 4. 2, 5. 2. Yeah, I'm pretty sure this one looks to be deterministic as well. 1, 2, 3, 4, 5, 6. Oop, 4, 6. That's 5. 1, 2, 3, 4, 5, 6, 7. 6, 7. There's kind of a 7 in it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah. Also pretty confident that this one only has one solution. Now this one is an 8x8 where my algorithm deterministically completes. Let's see if we can confirm manually quickly. 1, 2, 4. So 2, 2. Whoop. 1, 2, 3, 4. 3, no, 2. Let's just see if we can deterministically confirm this. 2, 1, 1, 2, 3, 4. That's a 3. That's not a 2. That's not a 1. Okay. 2, 4. That's a 1. That's a 2. 1, 2. Yeah, it's SudokuPad isn't really well equipped for this kind of thing because it doesn't highlight these properly. I wonder if I could add... The problem is I don't think I can add cages. Wait a second, maybe I can add cages. I'm not sure if SudokuPad... In theory, it supports overlapping cages. I don't know how the checker deals with that. Let's go back to the 5x5 and add cages to it. And see if, for example, I can put a 3 here and get it checked. Wait, here it works. It does... It does on the 5x5. Oh, I think on the 8x8, because on the 5x5 it does row column checking, but it won't be correct. And here we have a conflict with the givens, so it doesn't auto-generate the cages. So if I put a 2 here, it won't do. Okay, so let's see if we can manually add the cages to the puzzle data. So the puzzle data is getting created here. I don't know why I'm outputting this 3 times. Oh, because I think I put that into script.js here somewhere. G2343. 2343. Load CDC puzzle. Did I not? Have I not refreshed this in so long? So we do this here. Okay, yeah. So this is the puzzle we're creating, the puzzle data. So currently we're only adding the lines and the actual givens. But now for each range, we should be able to generate a cage. If I can recall how cages are determined, how defined in the data set. Can I open frame in new tab? And if I look at framework.app.source puzzle, cages look like this. Now the question is, can I overlap cages? And I'm pretty sure I can. So, we basically want to create... Okay, so if I do cages, and then we'll do 4 const range in ranges. Then we do, if I just do that. Let's do it there because we need that as a reference. So if I do this, ranges is not defined. It's hidden in here. Just recalculate them quickly. Doesn't matter. So if I do this, right? That doesn't look right either. Is it ranges? Oh wait, it's not in. It's off, isn't it? Yeah. Newfangled JavaScript syntax. Don't ask me about that. Okay, so we have 26 ranges. Each of these ranges looks like what? Wait, what? Why are they... Why is getRanges so weird? Is everything so weird? Is getRanges before and after the solve different? It could be because I'm writing global data all over the bloody place. Why is it in, like, why is it an array of single digits? What? getRanges. Parse R. New set. JSON parse R. Oh man, yeah, I tried to be super clever here. Oh, why? JSON.stringify array. Givens? We start with the givens. Okay, we're only using the givens really as a map of indices, right? So that gives us just the numbers 1 through n, one for each cell. Then we convert those to x and y coordinates here. Then, for each coordinate, we calculate the horizontal and vertical ranges. So RH and RV are functions that basically take this coordinate, find respectively the next left to the left and to the right and above and below lines, and then they return a list of ranges for those. Sorry, not a list of indices, the first and the last. Then what we're doing is we're creating an array with that many elements, and then for each element we calculate the number... Wait, what? We convert these to the indices, but we map them to array elements for some reason. What? But it still works? Okay, and now if we take that out, how did that work? How did that work? What the hell? Wait, what? Ranges. Digits I. Console.log range. How did this ever work? Because we're calling flat. Is it because we're calling flat somewhere? Wait, where are these? Yeah. Now, if we change that to how it was before, which basically wrap each of these numbers into an array of one element, then the range would be a list of array elements. This is bizarre. I don't understand how this works. Because then we are doing constant I of range. I, D. And here, is I an array or is I oh my god, we are outputting so much stuff. How? Is it because it converts the array to a string and it kind of still works? Oh my god, that's what it is, isn't it? It takes the array that contains 40. So if I take this and I say toString, it just returns 40, and that works as an index, which turns it. Oh my god! All right, that is insane. That it's so wrong, and it just sort of, kind of, somehow works out because JavaScript. So it just accidentally happened to work. Okay. Okay. I'm still learning things about JavaScript. So if you're just using it as index into an array, you can pass arrays with single numbers in them. And it'll work just fine, apparently. Okay. One second, let me just check some of these chats. See if there's anybody saying anything interesting or important. Maybe not. All right, so what was I checking again? I just had my mind blown a tiny little bit. Oh, yes. So I wanted to know if the ranges before and after were the same? Question mark? Yeah, okay. So I'm pretty confident now that the ranges before and after the solve are the same. So for example, this is the first row. This is the first column, I guess. So they're kind of mixing, across, down for each cell. So now the idea is, for each of these ranges, we should be able to create a cage. And I think what we're going to do is I'm going to slice this to one range and then see what it looks like if I turn that into a cage, right? So the cage would have to look something like this, where these are the XYs, right? So we needed to map them to XYs, and for that we need size, but that's a global variable at this point. Right. Right. So we can do range.map, I, and then that's just an array, right? So we'll do I modulus size, and then math.floor, I divided by size. And in fact, I have a function that does that somewhere. I'm pretty sure of that. I think it's idx to xy. Yeah, I think I can just do that. I can just do that, right? Boom. Oh, but it does XYs instead of arrays. Blech. Alright, we'll still have to map it. Alright, good enough. So that should give us... Oh, but I think they're in reverse order, right? Because then they go into row column, which is y-x. Rows are y and columns are x. Uh-oh, where is... Did I just lose my killer Sudoku puzzle? Yes, I did. I just want to look at these cage definitions. We can put in a sum as well, but we'll just need the triangular number for that, which I'm just gonna look up. I think it's in here. Right. Yeah. This doesn't deserve more than one line. So we've got that. That's basically the cells. Right? Unique, true, value, triangular number of range.length. Boom. Okay. Value 36. Is that correct? 1 plus 2 plus 3 plus 4 plus 5 is 15, 21, 28, 36. Yeah. Cool. Cool. So, puzzle.cages.push. Puzzle.cages.push. And we'll just do that. And we'll just do it for all of them. And now, if we do that, we'll have a ton of crisscrossing cages. So now if I put a 2 here, or a 3 here, or 1, 2 here. Now, how do we make the cages invisible? I should know this, but this is some stuff I actually carefully put into the code a long time ago. You know, styling cages and different types of cages and stuff, and I never ended up using that. And in fact, hidden cages. Find hidden. Trip hidden by hidden cages. Hidden solution. Find cages. Current puzzlet cages reach destroys undefined. Cage destroy. Region row call. Yeah, so it includes region or row call. If I make these of type row call, I don't think those are styled. I do this, type roll call. I don't know if type gets assigned that way though. So if I look at cages here, they're type roll call. But if I look at current puzzle after it's been parsed, what does that look like? Style killer type roll call. Type roll call. Type. Type roll call. Type roll call. Type roll call. Style. Sudoku region cage.style. Cage.style. I'm pretty sure cage styles are not on the renderer. I'm pretty sure they're on the puzzle object. Not on the timer, not on the checker, puzzle. Or not. Load puzzle. Type. Style. Killer. Cage borders here. Ah, it is on the render, okay. Killer box, window, selection, cage, extra region. Sudoku. They all have predefined styles. There must be the styles. The thing is, roll call gets generated without a style. But that's because they're being auto-generated. They're not included in the data. I'm not sure. Killer. Out cage. Style killer. Cage feature. What if I give it a style undefined? Does that count? It still renders the value. I mean, we don't really care about the value. So I do this, I still get the checking. Yeah, let's see, if I restart this and I say, okay, this is 1 2 1 2 1 2 1 2 1 2 3 4 1 2 1 2 2 3 4 1 2 1 2 1 2 3 4 2 1 2 3 4. So it looks like the highlighting is working now. Like here, it gives me the 4 immediately. Now it could trivialize these a lot, but that's really on the puzzle, not on the tool. I just want to make sure the tool works as you would expect. Well, okay. Okay. 2 3 4 5 4 6 4 6 1 3 5. So that's a 2 3 4 3 1 4 1 3 4 6 3 5 5. Okay. 2 3 4 5 6. Okay. 2 3 4. Do you have any other limited spaces? Okay, so 1 2 3 4 5 6 7 8. I think that fixes the problem with the checking. And that's actually a nice test of that feature, because I've always wanted that to be used. But, you know, I'm not a setter. I don't use it myself. And most setters don't know about this stuff. So it might be a good way to bring it out there, and then somebody might ask, hey, how do you do that? And I can say, oh, that's how you do it. So, for example, we have a triple here. The other question is, does this work now? If I do this, no, that won't work because that only works for 9 by 9, unfortunately. But I wonder if it would work for a 9 by 9 one of these. Although because they allow duplicate digits, it might be a bit tricky to enable that. Okay. 1, 2, 3, 4, 5, 6, 8. And 1, 2, 3, 4. Okay. Cool. Alright, that's a great improvement, I think. It's pretty about the value. Is there a type of cage where the value is invisible? Or do I have to apply this myself? Rendering killer cages. Rendering killer cages. Where does that happen? Where does that even happen? Does it happen in convert? In convert puzzle. Cages. Cages push. Convert filter. Splice. Parse cells. Value match. Okay. Cages handle cage feature. And cage style, cage style. Hot cage unique. Cage value. Cage value. I think you could potentially use sum instead of value. I think sum doesn't get rendered. If I do sum, right? If I do this, miss some rules. If I do this, promise, I don't think it'll make a difference because but what if we don't include a solution now? So if we do this without a solution, that'll be interesting. Okay. The problem is I always want the row column cages removed. Doesn't look quite right. Doesn't look quite right. So the question is then, does it come without a solution? Will it let me complete the puzzle, in other words? So I have to solve it again because I haven't got the tooling in place yet to make this faster and easier. 2, 3, 4, 3, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 5, 5. 2, 3, 4, 3. Okay. Any other more? We have a pair of 4s here, so no 4s here. It's a 3, 6. So is that? I guess that would be a hidden pair. 2, 3, 5, 6, 8. 2, 3, 4, 6, 7, 8. Okay. 1, 2, 4, 5, 6. No 2s here, so that's a 2. Okay. 1, 2, 3, 4, 5, 6. No 7. Oop. Here. All right. But we know no 4s here. And no 4 down there. Yeah, but this, unfortunately, my solver kind of happens to find the right solution on this one. But I still don't know if my solver is always correct. You know, like, does it give me false positives? That's the problem. And I'm not smart enough or willing enough to logic my way through that. One of these days I gotta have to figure that out, but it's gonna be a little bit time consuming. Okay. Okay, so this is a rare message where we are getting counted some expected 10, found 3. Wait, what? Here in cage. It's a 4-cell cage. The sum should be 10. What? Row 0. Row 0. Column 5. Row 1, column 5. Row 2, column 5. So this is a 4-cell cage in column 5. 0, 1, 2, 3. So it's this cage. 1, 2, 3, 4. It should be a sum of... But... that is not a sum of 3. The given digit is a 3. That's weird. That's very strange. If I check this again. Framework.app.puzzle.check. If I just do a plain check. Find check. Ooh. Where does check get executed from? Check. Alert on error true. Puzzle.check. Log true for each is not a function. What the hell? What the hell? This is bizarre. Oh god, features Dutch. What? The hell is going on here? So puzzle.check with app.check. App.puzzle.check. Oh, this is puzzle.check. Okay, did I misunderstand where I need to call this from? Okay. Fortunately, this is not the puzzle we're trying to check. So we're gonna do that, then we're gonna do that, and then we're gonna check. Okay, now it doesn't include a solution, that's fine. Okay. Now the question is, if I put digits in here, 1, 2, 4. Need to solve it again. Ah! Should have saved the solution. 1, 2, 3, 4. 2. 2. 2, 3, 4. 1, 4. 3, 4. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4. 3, 4, 4, 3, 2. 6, 7, 8. Boom. 1, 2, 3, 4, 5, 6, 7, 8. Boom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This can be a 4, 3, 6 here, 6, 3, 6. Okay. No 4s down here. 1, 3, 4, 5, 6, 7, 8, 3, 7. 1, 2, 3, 4, 5, 6, 7, no 8. 2, 4, 6, 7. No 7 either. So 6, 4, 2, 6, 3, 6, 5, 4, 6, 5, 6, 4. I need to save the solution so I don't have to. Oh, trying to use beginning and end to jump to the. That's good. That's something I should note of. Like what is my brain jumping to intuitively? What button is it expecting to work from muscle memory? I was trying to use like beginning and end to jump to the first item of a row or column, which could actually be kind of useful and should be something could implement at least via some sort of key configuration thing. This doesn't alert on error true, alert on no error true, log true. So okay, so if I fill this in, we get into this dialogue, but I don't think. I think the sum checking works. But how do we end up here without errors? I'm sorry, Dave. Where is that? I don't even know. Oh my gosh. Ah, there's a comma there. Here. So unknown. 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 Message unknown. Get dialog parts. Unknown. Turn. No. Get dialog parts unknown. Get dialog parts unknown. Get dialog parts. Is it just from message unknown? Does it just strip the message? Get dialog parts. Get dialog parts. Get dialog parts. Dialog type. Unknown. Puzzle has solution. Correct. Sudoku conflict. Puzzle.sudoku conflict. Cage errors unique length greater than 0. So if I look at framework.app.puzzle.sudoku conflict, it's true. Cage conflicts with givens removing. If I do that, is this the only place? But there should be a warn. SudokuPad. Enter solution, no. Framework.app.puzzle.2p81. Okay, so that's our solution string. Let's just keep that one handy here for a sec. So then, if we run the script again, clean up the puzzle, right? Then we say enter solution. Change conflict gives remove generated row call. But does that mean at this point Sudoku conflict is true? So if I set this to false, right? And we go back to here and we'll say enter solution S. Looks good as far as I can tell. Cage conflicts with givens, removing generated row call X cages. Okay. Does that get set over here? Conflicts, cage conflict with givens. Cage conflict with givens. There shouldn't be though. Is it because of the generated row column cages? Okay. Yeah, this is a little bit haphazard. So I'd like to either have this be more specific and only kick in on, because it's basically giving that unknown thing. Now, it shouldn't be a problem because we should add a solution anyways. But with the rules as they're set up, it should work, and it should work for puzzles with multiple solutions. That's the nice thing. So I need a way of preventing the row call X cages, like the auto-generated cages, because that's basically where that comes from. Remove automatic. So if I look for that, and then these get added, is there a way of preventing row call cages? Not sure. It always tries to add them. So the only way to prevent this is by... it's a bit annoying. Because the way to prevent it is with a solution, right? Because the solution determines... Yeah. Interesting. Interesting that I can force a puzzle that can be solved without checker. It's kind of annoying, actually. So if I do this here, just solve it normally without cheating in the solution. And I know I've solved this so many times now. It is what it is. 1, 2, 3, 4, 3, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 3, 3, 3, 1. 4, 2, 1, 2, 1. So this takes all the 4s out. So 1, 2, 3, 4, 5, 6. 2, 3, 1, 2. 1, 2, 3, 4, 5, 6. No 7. No 4, no 7. 3, 6. Zoom, zoom, zoom. 4s and no's. 2, 3, 4. Okay. 6, 7, 8. 6, 8. 5, 6, 8. Okay. 1, 2, 3, 4, 5. 6, 7, 8. 1, 2, 3, 4, 5, 6. 2, 2. 6, 4, 5, 4, 6. This can't be a 4. So that pair here. I don't know if that's a virtual pair, what the name for that structure is. And I don't know exactly what would be a simple algorithm to detect that easily without kind of just looping through everything and trying everything. Oh, no 9. So 7, 3, 8, 7, 6, 4, 8, 7. 1, 3, 5, 6, 7. I'm now curious what is the under this. So it gets this. This is kind of what we want. Now the question is, can I do this for the puzzle with the 2 solutions, which I believe is the last one, or the puzzle without a valid solution. So if we do this, right, and we'll just ignore the fact Oh, we just don't even do this, right? I'm just gonna do this. Because we're not actually adding the solution to the puzzle anyways. Where's this failing? So if I just do this. And this is this puzzle. And now this one is the one with 2 solutions, right? That's I think what we determined. So now at least we can play it. We can see what that looks like. All right, so 3, 4. Wait, what? Yeah, so here, because it has the built-in rows and columns. How do I stop that? Let us manually just break that for now. I'm just curious what it would be like if we don't have those. So, so we gotta look for this. Eek. So if I do this, right? I'm gonna do this. Do this. And I'm gonna do this. Yeah, what's a length check? Plus isn't gonna work. Dot push. Push, no. Let's hope that doesn't break something down the line. So if I do this, right? We do this. So we get that. Framework.app.puzzle.sudokuConflict equals false. We'll reset that. So now in theory, it shouldn't have row column checking enabled. Right? So we should be able to write this in, and it should not take that one into consideration for that, which works, which is very nice. So no force here. That's a 3. That's a 1, 2, 3, 1, 1, 3, 2, 2, 3, 2. So that's these are 3. Okay, so that gets us this. 1, 2, 1, 2, 1, 1, 2, 3, 4. All right. So far, so good. So far, so good. 2, 1. Like that. Okay. What's the next shortest ones? These are 5s. So 1, 3, 1, 2, 2, 3, 2, 2, 3, 2, 5. That's 1, 2, 4, 3. It's kind of almost working how I want it to. I mean, I'm hacking the engine a bit, so this wouldn't work on the existing engine. I'd have to update it. And the least destructive update would basically be a flag on the puzzle, I guess. Although I don't like those. Those are a pain to support long term. Okay, that's a 1 there. 2, 5, so that's a 1 there. That's a 1 there. Okay, any other shorter runs that I can verify? So, for example, because I'm going to say we have a 4 thing set up again with 4s here, but because that can be a 5 or a 6, it's not going to work. So these are all part of full runs. So 1, 2, 3, 4, 5, 6, 7, 8. But for example, here we can get rid of these. Here we can get rid of 1 and 2 and 8. Here we can get rid of 5 and 7. 1, 3, 6, 3, 6, 7. 1, 2, 3, and 5, 6, and 7. Now those were all the easy eliminations, right? Now this is, I think, very close to the state we had earlier. Oh, I'm so tempted to try to save it somehow so I can restore it. But now the idea is basically, will this accept either solution? So if we just, you know, randomly, so we're starting with the lowest value in the upper left corner. So we'll try this, see if we can solve the puzzle and it accepts it, and then try solving it with the other solution and see if that also gets accepted. Because accepting puzzles that have more than one solution is difficult with if I'm relying on the given solution mechanism. But for some types of puzzles, that might be very much desirable, right? So we might want to be able to do that. And 2s are here, here. All right, and next one is this 2, 8, 2, 5, 5, 4, 7, 4, 2, 8, 5, 4, 5, 7, 4, 5, 3, 4, 3, 6. 7, 4, 6, 6, 8. Yeah, this looks very much like, even just looking at these numbers intuitively, my brain says, hey, this doesn't resolve to a unique solution. So I'll do that. Let's just see what happens when we fill in like this. So it accepted this. Now, if we go back to the last time so here I just did a 3. So if I did a 4 now, is that gonna work? 3. And now we have a deadly pattern. And that's gonna be an easy test. So it likes this one. And it accepts this one. Okay, so these definitely don't have unique solutions. All right. Oh man, that would be nice. So this kind of checking would allow for a more, I want to say complex, but complex in terms of not standard Sudoku rules. The thing is, right now, out of the box, the engine doesn't quite support it. Because basically we need to get rid of the row column cages, which can happen, but we don't have full control over. And that's really all we need, I think. But then we need to be able to turn this back in. Cage error is unique. So the question is, can I make this happen instead of doing this and then removing them? And I'm gonna check my git diff here. If I just skip the auto generation of cages up here. So basically if I just skip these, right? Is that gonna have the same effect without me having to reset that variable afterwards? Come on, update. So we're skipping G186 something. Don't need that. Need that right now. So if we're doing this now, let's refresh this and rerun this. And I should have saved the solution. All right, all the 1, 2s, all the 1, 2, 3s, and all the 1, 2, 3, 4s. Right. 2, 1, 2, 1, 2, 1, 2, 3, 1, 2, 3, 1, okay, 3, 2, 1, 1, 2, 2, 3, 4. And then these are 1, 2, 3, 4, 5. right? 4, 3. Okay. And 1, 2, 3, 4 here. That. 2, 3, 4, 5, 6. Okay. 1, 3, 4, 5. Okay, so the 1 goes here. Oop, no, wait. 1 doesn't go here. If that could also be a 1. Definitely does not go there then. And then we have, we've got a 3 here. 1, 2, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7. So now we basically just gotta go back filling in all the digits, picking a potential solution, and then, you know, doing all that. 1, 2, 3, 4, 6, 7, 8. 7, 6. 3, 4, 5, 6, 7, 8. 7, 6. 1, 2, 3, 4, 6, 7, 8. 6, and 3. Was there not more than this? Could I not reduce this further? 1s, 3s, 2, 5, 1's here.
I know this inching.
Oh, there's a 1 here. Oh, okay, no more 1's. Solved all the 1's. Although, I'm not sure how accurate that is because we don't include a solution here. So I'm surprised it's doing the counting at all. Because it says 9, but of course there are 9. Because it's an 8. Ah, wait, no, there are 9.
They're more than 9, actually.
Okay. So that count is not going to work. All right. All right. 8, 7, 8, 4, 6, 8, 3, 2, 4. Okay. So I think before we got to a deadly pattern down here. So if I start here, maybe that'll resolve itself earlier. No, actually, the problem is there's actually so many different, there's probably quite a few possible solutions. I probably should still write the algorithm that just finds them all. The problem is right now I don't trust my current solving a partial solver to be completely unique. Ah, wait, there we go. There's another one. 2, 5 here. That is a 1. But that's about it. 5's here. Okay, so we take like a big one here and we'll just say, oh, okay, let's say this gets the 7, right? And a lot of places need 7s here. Does that help us? Like, is that a unique choice? Putting that 7 there. Doesn't even look like it, does it? It's not super helpful. 4 here. 6, 2, 4. I just want to see if there's some other branches that I can completely exclude. Or is, like, from here on out, everything possible, basically. 2, 8, 4, 4, 1, 4, 3, 4, 5, 5, 5, 7, 6, 7, 8. 8's here. 6, 4, 7, 3, 5, 3, 5, 3. Pick one. Pick one, spurn the other. 5, 3, 8, 5, 6, 7, 6, and 8. Okay, and if I back off to where I think I put like a... Yeah, so if I make this a 7... lots of deadly patterns, right? And then we'll just pick whatever. And well, another deadly pattern here. Yeah, so that would be the right thing to do. I put that. Yeah. So all I really need is to be able to exclude the auto generation of cages. And it's not really a risky thing because it, you know, especially if I make it an explicit request by the puzzle, So let's say, so for example, I don't know, if I say no row call true, right? So we'll do that. We'll run this. Actually, no, we first need to listen to that. So we'll go here, save that, refresh that, rerun that. And then somewhere here, it'll be here. And hopefully it has metadata. And then it'll say no row call equals true. It shouldn't really be under metadata. But I don't think there's an easier way of injecting that into the data and have it carry through. So, and it's already not generating regions here. So if puzzle.metadata dot no row call if it's not equal to true, and do these basically. So if I do that, refresh that, do that. And now framework.app.puzzle.sudokuConflict is false. And we still don't have a solution here, right? If puzzle is not equal puzzle metadata. So one last go around. We'll do all the 1, 2, 3s here. That's a 1, 2, 3. No other 1, 2, 3s, right? Then we'll do all the 2s. There's only one. Then we do all the 4s. Ah, there's another one here. 4. That's a 1, 2, 2, 1, 1, 2, 2, 1, 2, 3, 1, 2, 3, 1, 3, 1, 2, 1, 2, 3, 4, 1, 2, right? 1, 2, 3, 2, 3, 4. Okay. So this is the last check on this particular thing. These are all our 5 rows. 4 here. 3, 4. 2, 2, 5. And that's a 3. It's 4, 3, 4, 3. 1, 3. Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. One over here. That's a 1 here. That's a 1 here. Okay. Oh, what do we have down here? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7, 8. 6. 1, 2, 3, 4. So I'm basically teaching my app to be a little bit more relaxed. It's strange because you'd think that's a default behavior, and it's strange that over the years the app lost the ability to be more relaxed. But if I want to allow more non-Sudoku stuff, and we definitely do want that in the long run, and to be honest, we always wanted to. So we definitely, this might definitely be a step in the right direction. So I don't remember what I did earlier here to kind of limit these. This is a 4. That does a whole bunch of things, I think. Or maybe it does less than I thought it would do. 2, 4, 2, 5. That does a lot less than I thought it would do. Thought it would force something up there. That's a 6. Now that'll be something like that. 5, 4, 2, 5, 2. 8 here. 4, 2 here. 4, 3. 2, 3, 4. It's actually a 6 now. 6, 6. Okay, so that's resolved a whole bunch. It's no longer 5. 3, 4, 3, 4, 5, 6, 7. And now this is where we have our deadly patterns, I guess. There's a whole bunch of them. Let's just solve it some way. But the nice thing is any of the solutions should come through. Yeah. So that's a backwards compatible safe change, I think. It is something I would want to version bump though. And I haven't done a version bump in holy moly a long time. npm run bump minor. Right, and what would this be? Add add metadata.no roll call flag. I think the name is pretty self-explanatory to remind myself what this is gonna be in the future. Okay, cool. But whoops, one thing I would love to do is, well, we could leave the solutions out now if we don't have one. Okay, let's see if we can pass in a bunch of puzzles, and then whenever there isn't a solution, we'll do a thing, right? So we'll first of all reduce the amount of noise. We'll do solve here. Right. If solve fails, in fact, why don't we... Oh, because solution.length, solution.split. Solution is a string of digits, right? So we're gonna do try match error. We'll just have that here and put that there. Right. Error solve failed. But that's fine. Promise pending. And if we don't do this, right, and we just have the puzzle data here, we'll just say solution. We kind of just want to skip them for now, don't we? So we can just say return. Boom. Now if I do more than one, what does that look like? Get a solution. We get a puzzle. So we kind of want to... We don't want to log this out. Well, we do. I just need to figure out what to do in the negative case, right? So solution that, blah, 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 solve failed. Error solve failed. Oh, because we do a return here. So if solution.length yada yada, if solution.length is greater than 0, puzzle dot metadata dot solution equals solution. Right? So one of these will have a solution in here, and then one of these will not have a solution. Okay, I'm fine with that. And then in the end, we can just do a full whatever, right? And we'll skip the logging here as well. Okay, and now what I really want to do is we'll have this little thing, right? And then we have a bunch of puzzles in here. So we want to map this. So we kind of want to do this dot map p.data, right? So if I do this, I should just get a bunch of strings, right? And some of these strings will start with an A. So we want to filter those out. Dot filter D, where D0 equals A. Except we want to probably do the reverse of that. So that gets us the 4 with A's. So we want to get rid of those. Right? Boom, 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 boom. And then we basically just want to put those in here. Kind of like that. Right? Something like that. And then we get something like this. And then don't actually know why it's async. Is it literally just the hash function? God damn it. All right. Let res equals boom. Res dot push. Boom. So if I do return puzzle here and no console log, boom, right? So that should get us this many puzzles. 236. Let's remember that number. We can actually do this, right? Dot length. And then we'll take res dot filter p, where p dot metadata dot solution undefined dot length. So we should get a number and then a small number. So we have 217 puzzles here that seem to have a unique solution. And if I go the other way around, right, we've 19 without a solution, right? And I think if I do something like this, I think it'll show up collapsed, right? And let's do also this, console.time. We'll do that. I'm curious how long it takes, actually. Shouldn't take very long. Now, if I did a kind of lazy, simple algorithm for finding all the solution, might take something. So 131 milliseconds. So less than half a millisecond, well, around half a millisecond per puzzle. I wonder what's, if the asyncness or just number of function calls or something. I don't know. Seems like a long time, actually. Feels like it should be a lot faster than that. I wonder if it's all about the function here. If I say hash equals, if I just do this, is it the async of the hash? Well, it's almost half of the time. Huh. Don't know what else would it be. I'm not doing anything really complex here. All right. Wait, what? So that's the output. Makes sense, right? That's the 19. That's these guys. What's this? Oh, I had that piece of code copied underneath. All right. There we go. So these are the 19 puzzles that don't have a unique solution. And we can see most of them are fairly big, but some of them are small. I think I'm gonna do a little cheaty trick. Dot map p object dot define properties. My God, where did I do this? Basically using getters to create an unfolding item in a console that executes code. So if I do this on the puzzle, I don't remember the syntax. I kind of sort of do, but I don't feel like guessing. So if I just want to have something like, if I want to have something like load, then have a getter, something like that. Like if I do this, and I put that in here, run that, then I look at these and I open one of these and then I click on load, it should execute that. And I should be able to just execute that code up here. A little trick. Little trick for extreme console shenanigans, right? So let's find that 5x5 puzzle, array 5. Click on load. There we go. So this should have a solution now. Load it, which means it should have, as far as I know, not have a unique solution. 1, 3. 1, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm already seeing, like, it feels like it doesn't have enough. It doesn't have enough. What's the word? Clues. Doesn't look like it would have enough clues. Oop, no 6s. This is a... But it's good that I found a small one because it makes it a lot easier to verify. Yeah, this... No way this resolves uniquely. So if I put a 3, 5, 2, 1, 3, 1, 4, 3, 5, 2, 1, 5, 2, 4, 5, 3, 4. So that'll get me that. And then, oh, wrong button. No. And of course that won't work because we weren't actually at a link for a puzzle. Let's do it again. At least it's very short. All right. So 1, 2, 1, 2. Oh wait, why am I not on localhost? Let's do this again. Make sure we're on localhost with the new code. So the cage checking... Oh, because there's no solution included, yada yada, without the roll call removal. Yeah, it'll fail that way, okay. Alright. Yeah, and then that's it. That's all the clues, right? Then the rest is just not unique. Four, 1, 4. And I don't think it's not even anywhere near unique, right? It's like... It's not like, oh, there's just a little bit missing. No, it's like most of the puzzle is missing. Not much of a puzzle here. 2, 3, 4, 5. Yeah, that's not resolvable, right? And then you just fill it in however you want. I wonder if that's like part of the format, or if it's just, you know, these puzzles slip through the crack, or the algorithm, you know, or the algorithmically generated, and these weren't checked thoroughly or something. I wonder. I wonder if the originator of these is aware. Ooh. Wait a second. Did I feel like I screwed something up? It would also be nice to know, like, that there's a situation where yeah, you see, for example, we're missing 1 and 3. Oh, what am I doing here? Why am I going up to 6? Wait a second. Let me just restart that. 1, 2, 1, 2, 2, 1, 2, 3, 1, 3. All right. 1, 2, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4. 1, 3, and 3, 5. 1, 3, 4, 5. 4, 5, and 2, 3, 4, 4, 5. Okay. So, unfortunately, I forgot to memorize which digit I filled in. So now I don't know if I made a mistake before, a simple one, or if I came across something fundamental. 2, 3, 4, 4, 4, 4. So if I do this, that's why you should always be systematic. I should always start with the upper left lowest digit, right? Don't know if I just made a mistake before. 5, 2, 4, 5, 4, 2, 5. I mean, I should just build the algorithm that finds all the solutions. That would be the solution, right? But it works. So let's see. So that's a 5 by 5. Let's try the first 6 by 6. So that's a 1. 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 2, 3. 1, 2. That's a 1, 2, 3. That's a 1. That's a 1. Okay. 2, 3, 4. Okay. 2, 3, 4, 5. 2, 5. So 4, 5, 6. And 1, 2, 3, 4, 5. No 6 here. Okay. That's another 5 in it. 1, 2, 3, 4. Another 4. 1, 2, 3, 4, 5, 6. Okay. 2, 3, 4, 6. 2. I don't. 2, 3. My God, sometimes I miss the obvious ones. I think that sometimes like your brain gets blind to certain things. 3, 4, 6. Not a 4. 1, 2, 3, 4, 5, 6. Not a 4. Yeah, I think this is as far as it's humanable, solvable with logic, and then here on out, it's just not a unique solution. Yeah, I mean, I would probably exclude these because they're not that much fun. Now, if I do the opposite on the filter, where's the filter? Where's the filter? So if I do this, right? And now we can say, we should probably sort them as well. I mean, we could sort, actually, this had some sort of rank number in it, I think. No? Data, date, order. An order number. Okay. So if I sort them by order, so if I do this sort p if we sort them first, actually no, if we sort them down here, if I do sort a b parse int a dot order b dot order minus parse int a dot order. So if I do something like that, what does that look like? Minus. How does that actually sort this data without the mapping? So if I look at the first three, order is very high. Okay. So I probably want to sort them from low to high. I don't know what the order means, but I'm guessing that is some sort of intent in the original data. I don't know if the order is... Like, what does negative mean? These are small puzzles. What if you order them by date? How... I don't even know. Like, how do you convert... how is this related to date? If I just do this. Times 1000. March. What if I do that, huh? Dot map p dot date dot seconds new date times 1000. Do that. What do we get? If I look at these, so they're all in a certain time frame. That also kind of makes sense. So we could sort them by this date number. Are they? Yeah. So I don't think the nanoseconds are actually gonna be ever useful here. I'm pretty sure this is just, you know, the actual dates that this is supposed to be. I'm guessing the creation date. So they were probably all created this year. So we could sort them by those as well. So let's just see what that would look like, right? So we don't actually need to parse them because they're already numbers. Just a.date and b.date instead of that. So if I do this, so now they are sorted by this date order. Cells 4. Are they really 4x4s? Oh, they are. Okay. 2, 2, 2, 3, 4, 2, 3. Is there other data in here? Is there anything like difficulty or anything like that? That'd be nice. I mean, we have the sizes and roughly, you know, they sort of kind of get more difficult as they get bigger. One thing I want to look at. This is a 10x10, which my parser currently doesn't handle because it just doesn't know how to handle the A's. But I'm kind of curious because it has the corners excluded, and I'm wondering if that's determined, if that's set up in this here somehow. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. That's 10, right? So these are the given digits. I think. 1, 2, 3, 1, 2, 3, 1, 2, 3. 2, 3, 1, 2, 3, 1, 2, 3, and 10. And now these will be the lines. And they are 11 times 2. So 11 times 2. And 11 of these, right? I think that's what I figured out about this format. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ah, I see. Is it? As you see, you can kind of tell the shape just from the digits in here. I wonder if... So 0, 0 is the bottom right corner. Like, that's outside of the board. But basically, in the puzzle that I've seen this from, and I think Ranks did a video on that. And it wasn't this one. Let's see if there's another one. Yeah, it was this one. These were blacked out.
This.
But do they need to be? Because I think the blacked out is literally just enclosed 1x1s. I think that's basically what happens. So whenever there's a cell that has a bar on each side, it just makes them black. Let us see which from the data set, which one it is. What if I do this filter? That should get me all of the ones that have p dot data. If I do that, right? We get 4 of them. And one of these will start with a 1, 1. So it's this one. So that's, whoops. So I'm presuming that is the ID that I need. So I haven't actually figured out how to open these puzzles on the site. So if I say play and I put that in there, does it load it up for me? Yes, yes it does. And is that the right one? Oops. Where are we? My brain. Yeah, okay. Now, to bring that into SudokuPad, I'd have to do a bit of finagling. You know, 8, yeah. But so, it just has a 10 here. And it just tells me that's wrong. So the cross is basically when it's impossible. And interesting. I wonder why it doesn't take up the full size of the... Like, it does like this. But like this, it doesn't let me zoom in. It like it forces me like into this smaller view for some reason. It's probably some sort of predefined mobile shenanigan bollocks. I don't know. Alright, and this one is a tough one though. So I can put a 1 here. If I select... Oh, I can't select multiple. Oh, that's annoying. So it uses 0 as 10. 0 as 10 is a feature in SudokuPad, so I should consider implementing that as well. So then presumably one of the other 10x10s isn't as hard. Okay, so I can also do this. And that'll get me all the ones that are 9 by 9. I can put this filter earlier. I can just say p dot data is not equal to a. All right. So if I do this, now I should get all the 9 by 9s on the list, sorted by the date number. Let's have a quick look at the. Oh, it doesn't give us the order number here. Let's look at this again. A sec. Here we go. I want to see if the date and the order correspond in any way. So these are sorted by date. They're not in the order of whatever order is. Interesting. And I don't know if larger means better, but let's sort by order for a sec. And then just pick the last one and hope that means it's the best one. Not that one, not that one, that one. And then if I do this, it should load it in. And let's see if we can solve it. Oh, okay. 3, 1, 2, 1, 2, 2, 3, 4. 1, 4, 3, 1, 2. 3, 3, 4. 3, 4. Okay. 1, 2, 3, 4. 2, 3, 4, 5. Not 6, right? Because we're in a 9 by 9 zone. 1, 2, 3, 4. That can be a 5. 3, 2. This could be a 5, yes. 1, 2, 3, 4. 3, 2, 1, 3, 4. 1, 2, 1. Okay. So that's 1, 2, 3, 4, 5. 4. So these should have a unique solution, and they should be solvable fairly easy because my solver is not very smart. 1, 2, 3. That's 6, right? So, okay. These are. That's also 6. 1, 2, 3, 4, 5. Okay. 3, 4, 2, 1. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4. Not a 5 in here. Hmm. 5, 4, 2, 3. 5, 6, 7, 9. So this one is 1, 2, 3, 4, 5, 7 long. So no 9s, no 8s. 8, 9. 1, 2, 3, 4, 5, 6, 7. And no 8. Okay. This one is 1, 2, 3, 4, 5, 7. 7. 3, 5, 6. Okay. And this one, 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. Except this one is only up to 5. So this can't be a 6. 4. This is only 1, 2, 3. So this has got to be a 5, 3, 4, 7, 6. All right. Oh. Not a 5. That's a 7. All right. 1, 2, 3, 4, 5, 6, 7. All right. So 1, 2, 3, 4, 5, 6, 7. So this goes up to 7. So we have to have a 7 here or here. So the 7 goes there. 1, 2, 5, 4. 5, 6, 7, 8, and 9 here. 2, 3, 5. 1, 2, 3, 4, 5, 6, 7, 8 here. 1, 3, 5 here. All right. All right. So far, so logical. 5, 6, 7. So it's 1, 2, 3, 4 here. 1, 2, 3. 4. It's the only place of 4 in this row. This row. Okie. 1, 2, 3. 1, 2, 3. That's a 5. 3, 1. 3. 5, 1, 2, 1, 2, 4. 1, 2, 4. 2, 1. 3, 1, 3. 2, 3, 1, 3, 2. 3, 4, 1. Yeah, all right. Okay, this algorithm works pretty well now. And the whole multiple solution thing, it's one of those things. I could have banged my head against the wall for a long time and not have thought of it. Especially when I don't trust my algorithm, which I, be a fool too. All right, let's see if we can just... So now that we have the IDs, we don't need these references anymore. Yeah, I was just keeping that because at the time I didn't have IDs. Now I have the full list. That's just the same thing that's down there. Okay. Yeah, I don't know how I'm gonna turn that into something valuable. It's mostly just me monkeying around. Because these are not my puzzles, so I'll probably give the code to the author of the site and let them decide if they want to publish them or how or when or whatnot. Or maybe beef up their security. Okay, so the subject today, and I have so many pending things with little bugs and stuff that I need to look into, and it's a bit overwhelming because I'm like multiple browser tabs deep into things that I ought to do, each of which can split out into a large amount of work. But one of the things I need to work on is the customizability of the interface for the 9x9 project and for ranks and for everybody else. And part of that I've been working on in recent streams. So there's two main aspects. One is like layout and where things are, and the other and then, well, three aspects, right? The layout, where things are, the things, what is there and what isn't there, adding, removing buttons, hiding features and so on, and visual styling. And I'm gonna look at my meeting notes, which are one of these tabs. Ugh, how far in? Okay, is it this to T? Oh, no. Where are my meeting notes? Where are, here we go. Geesh. They're so important, I wouldn't find them. Yeah, so I basically need to look into the primary interface icons. So they asked me basically, the 9x9 design team said, okay, what are the icons? Maybe we can do a pass. So what I want to do is, I have a page for that actually in the app, which for some reason Windows can't frickin' find, which is so sad. Windows, like, hello, where's my SudokuPad? Do I need to reinstall it from Steam? Is it not installed on it must be installed on this computer, come on. Maybe it's not. Maybe it's not. No, it must be. It's just Windows search being very, very, very silly, right? Yeah, there it is. There we go. Okay. So I've done a thing here for this app, where I think I did this. And I need something that's most of the work, but at least what I have here is I have the images already set up and so on. And I was originally going to do it quickly as some sort of shared Windows Google Doc that I sent to them, but it's an opportunity for me to actually do this properly. And obviously I'll maybe do a draft first, but it's something that could be part of some sort of future documentation, right? So let's have a quick look into, yeah, and here's the to-do item for that, actually. Okay, cool, 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 cool. So let's have a look at this page from the app, which should be in here under, no, that's not it. It's under, wait. My brain is just gone dark. Yeah, no, it's in here, right? It's gotta be. It's gotta be. Oh yeah, no. Okay, well, yeah, okay. It's in here. Ooh, okay, so we have something like about help, and then we basically have this. And I just sort of more or less manually stuff them in there. Okay, that's fine. That's fine. We have recently added our first sort of documentation page, official documentation page anyways, under help. Slash help. Yes. Okay. So I'm just gonna do something like that. But for the icons, right? So we're gonna take most of it like that. Buttons. For now, this is not going to be a public page that I'm gonna publish. But I'm gonna build it as a public page, so in the future it'll be easier to publish it if I want to. All right, we just want to save this under SudokuPad app source help app buttons.html. Do something like that, and then here will be app buttons. Okay. SudokuPad buttons. To do this, I'm gonna have to run another script. SudokuPad.app npm run watch tap. Boom. So if I do this, it should restart that, and hopefully not screw itself too hard. Okay, and now we want to bring in some of these things. No, not these things. Did I close that page already? It was from the app. Oh. Okay. And I'm gonna reverse it. I'm gonna have the icon first, and then we'll bring it, bring it over, and then description next to the icon, right? So we probably just want to remove these. Like that. Oop. Did I do that already? If I restarted it too quickly, it'll crash. There we go. Oh, great. Great. Alright, let's try this again. So we'll do a diff. Just something so we can group the styles. Ooh, okay, that style is not great. I'm pretty sure those styles, though, are embedded in somewhere else. In somewhere else land. Somewhere in here. Actually, this might not even be enough. I can... Tool help, I can... Ah, okay. What if we do this? And then we'll call this tool help for now. Just to get us started. Okay. Jeez. How do I define variables again? So the styling for that comes from here. And we kind of want to look for this in here. Or somewhere. So if I do this somewhere up here, it's probably not good enough, right? Okay, if I search for that here, basically it's like root and braces or something, and I think that's all I really need, right? Can I root search for that? Okay, colon root. That's the piece I was looking for. It's a selector that for some reason I've never really seen outside of variable declarations. All right, here we go. Here we go. Hey. All right. How do I want to lay this out? Do I want to have the graphic on the right? I think that's okay. Maybe I'll just take the style from this thing anyways. So how did that go? So we had the icon first, and then we'll have something like that. Except obviously. And in fact, internally, I don't call it a number anymore. I call it, what do I call it? Normal. Normal. Right. And then we basically want to do this. Right. And then we'll take the other icon out of there, which there's probably a better source for these because they've probably changed, and I don't know why I was translating them here. Or is that really how they're defined? Maybe it is. But right now I'm actually more interested in putting this together quickly. So maybe this is the way to go. And I just clone it over. As much of it as makes sense. So all these tool help items, I can just grab them all, stuff them all in here, maybe align them just a tiny bit, right? And then I do this. Okay, and then I'll want to grab the missing ones from the framework file Framework starts with F. Tool select, here we go. So, framework tool select, I'm just gonna do this. And restart. Restart. And we'll have a restart phase 2. Is it this one? Maybe. Nope. It's something confirm. Confirm. So if we're in this place, happen the restart puzzle. How do I change the button here? Handle cancel. Handle soft. Handle option. Is keep time. Keep time. Start. Basically, I'm not sure if I'm just this change to the button. Is that just a visual change, or is that a different icon that gets... I think it's just a visual... I think I'm just colorizing it with the styles. Let's see if I can determine this. Confirm disable. Yeah, okay. It's just a colorization in the style. All right. So there's no second button icon for that. Okay. All right. So now let's look at these side by side. So we have the primary tools, 1, 2, 3, color. The color icon is no longer appropriate. That's an old icon. Okay. Oh, so it's 8:30. Let me think. I'm supposed to be heading to the airport. +8. Flight arrives at 10. Yeah, I'm actually supposed to be heading to the airport now. All right. I'm gonna shut down the stream pretty soon. Let's just see if we can get at least the main icons put together. Is it added here? No, I think it gets added by the color. It gets added by the color tool. Finish bloody sentences. Holy moly. Okay. Here it is. Right? That ought to be it. So, select. Gonna do corner marks, center marks, colors. So if I do this here and just do that. Oh no, this one's oh, it's generated. It's generated. Can I just grab it from here? Can I just grab the icon from in here? Copy out HTML. Do that here. Do that. That. Now check. I think that's accurate. All right. Okay, we're missing the pen tool, but I think that's not actually important at this stage. I think all the other tools are there, except for full screen. Find full screen. Find full screen. Full screen. Is that under full screen on? Okay. And we might actually want to put both of them in there. Settings. Notes and tips. Rules and hints. Rules or hints. Okay. Let's duplicate that. Let's throw this in here, and I think I can throw in 2 icons as well. We have this one, and then we have full screen off. I mean, if this is going to be obviously style reference is not the same thing as documentation, so full screen toggle. Toggle full screen mode. All right, so if I do something like that. Yeah. Okay. So we've got 4 primary tools. We have the 4 secondary tools, and then we have 1, 2, 3, 4 of the app icons. Skipping the info one, which is probably not relevant. Okay. That's actually kind of good. I'll need to go over the I'm just going to call this UI reference. I need to go over the details of the text, make sure it actually makes sense. UI reference. And I'll probably want to rename this. Rename UI reference. Do that. Okay. And I think that's actually fine now, like that. So if I look at what's changed on the site side, not much, literally just adding a page. And I think I can literally just push that straight up, right? Deploy server pages. So I can just do that, right? So this should just be available like that. All right, cool. That's it for today. I mean, this is just a small step. The theming, there's various things that I've done in the past that pushed in that direction. I already have color theming, but what I need for the 9x9 project, and let me see if I can quickly bring up the design. Yeah, so for example, we have stuff like this, right? So they have like a visual UI, so they'll have different colors. They maybe have different styles for icon, maybe different fonts and stuff. So, and a long-standing request has already been to change the styling at the top here. So that's probably what I'll start with. The buttons can be colorized, and maybe I'll have some way of just defining a sort of sprite sheet for buttons to just replace them. Although you could probably do that via CSS. So maybe I'll enable a custom style sheet and then have a way of like including the you know. So what that would require though is that all these buttons have appropriate classes assigned to them, right? Not these. The main buttons I haven't even thought about. Yeah, because right now you see these icons aren't labeled. So what I want to do then is basically each time one of these icons is used, I actually want to have a class, you know, an icon and then icon dash settings, right? And that's a refactor I can do to the site. That's basically a no-op, but that should enable much easier theming with just a style sheet, and it should even work through for testing purposes through like a stylus or any kind of style sheet injection thing. Yeah, and then the customization of the tools is one thing, and then the layout modification, I'll try to build a script that ranks can use initially that's maybe a bit rough around the edges, and then start adding sort of the main aspects of it, like the main settings to the settings, or to have a more complex sort of JSON configuration thing. but it can get kind of messy quickly. So without like an easy user interface, I'm loath to put like these kind of settings into user land, right? But it might be an advanced setting, not directly accessible through the user interface, but just like, hey, if you put these flags into your local storage, this is how it'll work, right? And maybe even some API where you can say framework dot set layout, and then boom, right? That kind of thing. All right, that's it for today. I know I spent probably more time playing the one-up puzzles. If you think this kind of puzzle might be fun for you, you can check it out at oneupuzzle.com with 2 P's. There's a uppo in the middle, UPPU of the oneupuzzle.com. Check it out. There's as far as I can tell, there's a daily puzzle and there's 5x5 training puzzles, a whole bunch. They're kind of fun. Check them out. Take care. Have a good day and see you in the next one. Bye bye.